Hello everyone, welcome back to my SDL2 on Xcode series. In this tutorial project, we are going to build the classic snake game on Xcode using C and SDL2. This is episode 4. Let's recall that last time we have built a window using our wt engine. And on the screen now, we have a white background and a red rectangle on the screen. So let's take a look. So now here we have the window. We have the white background and the red rectangle. Next, we're going to load some resources and then displace it in the screen. So to do so, we first of all need to create a folder that creates our assets. We're going to go to our projects folder. Within our snake folder, we're going to create a folder called assets and put all the resources within here. For now, I have some phones and I have some resources here for our snake project. To include this into our project, we're going to go to snake and then right-click, add files to snake. Now to this, we are not going to copy the items, but instead, we are going to create a folder references. And then we're going to go to the snake project, go to assets, and then we're going to add this whole project or whole folders into our project. If we do it successfully, you can see a blue folder here, representing a folder reference. If you go to the snake project configuration, and you can see here that in the copy bundle resources, you will see assets in the project. This is because we create a folder reference in our project. Next, before I go next, later on, if we add assets to this folder here, then it will automatically goes into our project and automatically go into our app. So that is the idea why we should use the reference here. Now let's see how we say load the apple, this image into our app and show it on the screen. We're going to go to the app.c in the structure here for our local screen. We're going to add one field called texture. That is to hold the texture we are going to load. And then in the code, we're going to say if we are going to, first of all, we are going to load it. And then texture equals to, I'm going to use the load texture function to load the texture from the file. So we need to put in the renderer. We can get the renderer from the engine directly. So get renderer. And then for this one, we have our apple at SS, and then snakes, and then apple.png. That is the path to our apple PNG. Let's double check assets, snake, and then apple.png here. So that should be able to load our apple.png into our texture. We should do some error checking. So see if our texture is loaded successfully or not. If not, we're going to log the error, and then we put the arrow here, and then we have the image get error. So, and if we should return false here, indicating that we cannot initialize the scene correctly. Now in the render part here, I'm going to draw the apple in on this screen. To do so, I'm going to first of all, let me set the x to be y to be 100. That means I'm going to put our apple at the at the position 100 and 100. We also need to specify the rectangle that we put our apple. We're going to make the rectangle just large enough to hold the apple. To do so, we can use the SDL query texture, and the texture we are going to query is the scene texture here. We are not going to query this one, not this one. For the width, we are going to store it into here, and for the height, we are going to store it in here. That will create a rectangle that is large enough, just large enough to hold the texture. I should use dot here. And then now we are ready to render this image. So to render that, we are going to use render copy. And then we will set the renderer here and the scene texture. So, and the source rectangle to be null, meaning that we are going to draw the whole texture. And for the destination, we're going to say this one. And that will be enough for us to draw the resources or the image on the screen. Let's take a look. Now you can see that the apple is now shown on the screen, which is good, meaning that we can do this successfully. Now, within the game, we have a lot of resources, right? And it is a better idea to develop some mechanism to load all the resources together, not in our scenes. But before I try to make some mechanism to do this resource loading together, let's try to see what kind of other resources we have and what kind of similarity among this loading process. Now we have the texture here. What if I have a font that I need to load? Well, for the font, we are going to use something called TTF open font, and that will open a font. You can see that here we are going to use the path and also the size of the font. And if we have some error, how do I get the error? Well, we are going to use get error. And finally, to close this resource, we need to use something like close font. Here, you can see that I should also close the texture we loaded here. In order to do so, I'm going to do it in here. We should check that if this texture is loaded, then we need to use the SDL destroy texture to destroy this texture to release the memory claimed by this texture. So I should say that for the texture, we have the load texture and we have the image get error. For resource unloading, we use SDL destroy texture. Now that's for the texture. And you can see that for font, we have another set of functions: open, get error, and then close font. And also for music, we have the mix function. I think load music, and then it takes a path as a input, and then we have mix get error, and also we have to free the resources, we have mix and then free music. You can see already the pattern. In order to load manipulate a resource, we have three functions: a function to load, a function to get error when there's something wrong when you load the resource, and there's a function to unload the resource you just loaded. So these are the pattern. And to be complete, let me write down also the chunk. Chunk is a sound, is a audio sample that will play the sound effect. For that, we are going to use load wave, I believe. And then to get the error, we are going to use the same mix get error function. And to free the resource, we are going to use mix free chunk. So we should build some mechanism that will respect three functions: a loading function, a function that will take error, and then a function that will unload the resource. You can see that we have four set of four kind of resources that we need to manipulate, and they share the same pattern. However, when we open a resource, you can see that they can take different argument. So other than the path, so we need to do some load function like load, and then we have a path, and we have some sort of other argument, something like this. And to get error, we just get error without any parentheses, and it will return a string to represent the error. And for this one, we should return a pointer to the resource. And finally, to unload, we just have a function that will take the resource like this. So that this three function is a summary of this pattern. We have the load function, we have the error function, we have the unload function, and that's it. And that motivates us to put them all into one thing called the manager. I have already defined it here. Let's take a look at the definition of the manager. You can see that for this manager, we will have a name for the manager, and here there is a array to store the items for this manager, and we have capacity for this manager, and then we have a load function, unload function, and the error function, and these three functions are defined just as what we expect. For the load function, we have a path and maybe some sort of extra argument, and for the unload function, we just have the pointer to the item that to unload. And finally, the error function will take no argument and return a string. And that is the abstraction of what we have discussed a moment ago. And then in order to manipulate this manager, we have to provide some functions. The first function is to resize the manager to hold all the resources needed. And then we have, of course, we have a function to clear all the memory claimed by this manager. And also we have a load function. A load function now will take 4 arguments. The manager that we are going to handle. The RID means the resource ID. The resource ID basically is an index that we store the item in this array. And then the path to the resource we are going to load. And finally, the extra argument that may be needed in the load function. And that is the core load function for us. And it will return the loaded resources as a pointer to that. And for next, we're going to have a getter to get the resources by the ID. And also, we should have a function that will set the resources by the ID. And these are the only 5 functions for our manager. And the implementation is not hard neither. To implement it, you will have a simple resize function that will check the sizes first, and then we will relocate the items field if necessary to hold more items. If we are out of memory, then we will say log an error and then return false. Otherwise, we will want to make sure that the newly allocated items are null, meaning that there is no resources there. And then we set the capacity to the new size, and then we return true. And that is how we resize the manager to hold more items. And another important function is the clear function, and that will unload all the resources first, and then unload the memory claimed by the array, and set the capacity to 0. And here, let me be more cautious. Let me put this one to null, indicate that we should not have any item in our array. Next, the load function is quite simple actually. We were going to use the load function from the manager to load from path with some extra argument. And if there is anything wrong, you can see that we now use our error function to get the error. If the resource ID is already used, we need to make sure that we unload the previous resource. And finally, we just set the item to that resource ID, and that's it. The getter and setter is not too hard. You just basically return the corresponding index and set the corresponding index with some caution here and here. Check the ID is within the range of the capacity, and that's it. So that is our manager. Now let's see how we are going to set up 4 managers for our engine. 4 means the texture, the font, the music, and also the chunk. These are the 4 managers we need. And we are going to add it in here. So you can see that in our engine header, we're going to add 4 more functions for resource managers. We have the wt engine get texture manager that will return a manager that handle or manipulate the texture. We have the phone manager, music manager, and also the chunk manager. And now we need to define this function. In order to define it, we're going to add to our engine structure 4 more fields: the texture, font, music, and chunk manager. And they are actually a pointer or a reference to some static members in this file, meaning that they are private members within this file. And to define this one, actually I define at the very end of our file here. You can see that in order to define this texture manager, I'm going to write a loader function for texture. It basically takes in no extra argument, only the path. And because we already have our renderer ready when our engine is ready. So that is our loader for the texture. And you can see that we set the name of the texture to be texture manager, meaning that this manager is mainly for loading images. And at the beginning, there's no items with capacity 0. The load function is this function here. And to unload it, we just use SDL destroy texture. And to get error message, we use SDL get error. And that will finish our first manager. Next, to get the font, we are doing the same thing. Only now, we need to be careful about the extra argument. In this case, we do need another argument indicating what kind of size we would like to have for our font. And so in this case, this extra argument is actually a pointer to an integer that will give us the size. So that's how we use this extra argument here. Now, to make the font manager is the same, we give it a name, set it to no items at the beginning, and a load function, unload function, and error function. Same for music and chunk. You can see that they are very similar because they are from the same library, the mixer library. The only difference is that we have a different loader function. One is using mix load music, and the other one is mix load wave. And they, other than that, they have different name. One is called music manager, one is called chunk manager. The load function are not the same. However, other than that, we have another difference is called the unload function. One is use mix free music, another one use mix free chunk. But they share the same get error function. That will successfully give us 4 default resource manager. Of course, if you are not satisfied with these 4 managers, you can develop your own resource management. And you are not actually bound to these 4. They'll just give you some default options. So that's it for this episode. In the next episode, we are going to see how we are going to use this 4 manager to load all the resources needed for the game.